Ready? Good to go. All right, so welcome. I'm Kelsey Hightower, and I work at CoreOS. And we're going to do a big brochure demonstration of CoreOS, or I'll actually go at CoreOS. So really quickly, who is CoreOS? So CoreOS Inc., the company that attempts to make money for our venture capitalists. We source projects. They're actually free and clear. And our main projects are the operating system, CoreOS itself, which is a minimal Linux distribution aimed at containers, right? So there's no package manager. And we have a couple other popular projects, etcd and Rocket. That's our newest project. And our goals are to bring distributed computing to the masses. Usually when I explain our company's role in the IT ecosystem is to provide Google-like infrastructure that you can download, right? So that's the goal. So today I'm going to talk about a couple of our key projects and a little bit about how we write Go code. The good thing at CoreOS, all of our code base started in Go. So we do a little bit of C and C++ on the operating system side. But every other project, every single project is written in Go. There's no debate, no choice, no meetings. It's going to be in Go whether you like it or not. And any features that are missing, we try to contribute to the standard lib or some other Go package. So it kind of makes it nice knowing that everything that you open up is going to be in a single language. When we do write code, we stick to mostly the standard library. So if you issue a pull request, bringing in like 4 new dependencies, that's going to be a long conversation. We want to just make sure that we're only bringing in things that we need. But that doesn't mean we don't use any third-party dependencies, and we'll see the ones that we take advantage of here. Everything we do is on GitHub, so we use GitHub for everything, issue tracking, pull requests, and we make things simple by just using Travis CI and the Golang testing packages for all of our unit testing. So really quick, some of the things that we do, since everything's written in Go and our OS distribution is slim, there's no package manager, so we try to statically link all of our Go binaries to the point where we use the Go native resolver, and we don't take advantage of things like SSL certificates being loaded by the Go runtime. So sometimes we stuff them in. If we're shipping containers, we will bind mount our SSL cert, so that way SSL tends to work. So a lot of people run into problems when they start statically linking their Go binaries. They throw it on the server and they realize they can't validate SSL anymore. So there's a couple of tricks there, but we solve it by either bind mounting in our root certs that are on our OS or actually packing the certificates in the Go binaries that we need. The next thing we do that drove a lot of people crazy, we haven't went to make files, but we do have build scripts and test scripts. And this is mainly for people that are new to Go. They download our project and they don't have a Go path set up. So we try to account for that by having wrapper scripts on how to build. It would do things like go get things that they need before actually building our project. But one of our rules is, even with these scripts, it has to be Go gettable, right? You can't punt on making it Go gettable. So Go get needs to work, the standard tooling needs to work, and then you can write wrapper scripts around that if someone wants to just type /build. And another thing is we vendor all of our dependencies using GoDep, right? So we check in all the source code, so not just the description file that GoDep provides, but all the actual dependencies that those projects depend on. And this is important too, because sometimes people get tired of being an open source contributor and they just like delete their GitHub repository, and you find out at deployment one day, and you will be sad. And we use the -r flag mainly to rewrite the imports. I personally am not a fan of rewriting the import URLs because it looks really ugly when you're looking at it. It's like all these GoDep paths. And it gets really tricky when you have multiple projects using GoDep. So when your dependencies also use GoDep, you're in it's a maze of who actually is authoritative for the import path. So I tend to stick to the rule of your main package uses GoDep, and all your libraries just assume that the caller or the main binary will resolve the dependencies, even the ones that you depend on. And right now, the ecosystem is young, so most of these libraries are at just 1.0. So maybe a couple of years from now, when we start seeing version 2s of things, will dependency resolving actually be a pain? So for now, I just recommend using GoDep, not with the YAR flag if you can help it. So like I said, all of our projects are written in Go. And we actually try to stick to whatever GoFump tells us. We don't write Java-style Go code. We try to write things the way that you would see it in the standard library. And we actually spend a lot of time making sure that we're writing code the best way that the community would want to see it. And the reason for that is when people contribute to Go projects, you kind of expect the code base to look a certain way. If you see a factory pattern with like the word factory in it, usually you close your text editor immediately and move on to another project to contribute to. And we want to prevent as much of that as possible. So here's some of our key projects. If you go to that, our Inc. or our organization on GitHub, you'll see the rest of our projects. So what I'm going to do now is step through our projects and actually show a small demo of each of them to show how they work and what key libraries we depend on to build those projects, right? So I think a lot of people that are new to Go, you hear people using Go for everything, but you don't actually see the thing that they're building, right? So we're going to try to do a little bit of that today. So the first project, one of our more popular projects is etcd. So etcd is like I guess the best way to explain it is the Chubby clone. So it's a key value store that's centralized, has built-in HA using the RAF protocol, and it provides a distributed or centralized lock service for your apps. And all of our applications take advantage of etcd in some way. So for instance, we have a overlay network tool that manages subnets for a cluster, and it stores its routing table in etcd. This simplifies the applications that we have to build. The key packages in etcd, especially the new version we just released last week actually, 2.0, we leverage protobuf heavily for the RPC serialization between the RAF nodes in the active cluster. We use the context module, which actually cleaned up the code base quite a bit. If you haven't read the blog post on the context module, you should check it out, but it's an easy way of passing shared state or context and things like deadlines and cancellation to other Go routines that actually do the heavy lifting to the entry points of your APIs. And Go RAF, so we implemented another RAF implementation. We started out with Go RAF, learned a lot. A lot of etcd servers caught fire in production, and we found that our RAF implementation was not up to par, so we rewrote it, and we have this standard RAF library that's being used by other projects as well. So what I'm going to do is give people a quick demo of what this looks like. If you have any questions, feel free to interrupt. I don't guarantee that I'm going to actually answer them, but you're surely welcome to ask. So with etcd, normally you run it in like a 3-node configuration, and you use the RAF protocol to basically auto-elect a leader. If one machine goes down, it will automatically hold an election and find the next node. So using those key libraries there, we can bootstrap an etcd node. So I'm going to do a static bootstrap. And what's happening here is it's sending RPC messages to a list of its peers in the network, but it can't find the other two. So right now, we're just going to spam these messages. We just use a simple Go logging package. We kind of gave up on complicated packages like glog. We just log to standard error, and we let tools like systemd route those logs to a central place. So no more debating on how logs should be formatted. So I'll start up the next node. And what we end up here is now that the RAF has established, we have RPCs confirming that we have a quorum in the cluster. And now our 3-node cluster, even though there's only 2 nodes who are present, are actually ready to start taking work. And we'll start up the 3rd node. How many people have actually heard of etcd? How many people actually know what to do with etcd? Yeah, that's what I thought. Most people like, etcd is cool. Like, what do you do with it? Like, I don't know. I just install it and show my friends. It's like, that's a good thing to do. Very impressive at FOSDEM. All right, so I'm going to stand up a little proxy. And some of the things that you can do with etcd, some of the patterns that a lot of people like to do are, let's see if we make sure that it's actually working. All right, so good, no keys are found. So what we can actually do is watch for keys. And we'll watch for key foo. So what will happen is, in this pattern, if you're doing, for instance, like in Flannel, when we have a new node that comes onto the network and it allocates itself a new subnet, we need to update the routing table for all the instances in the cluster. So what they'll do is come up and watch a particular key. And what we can do is write to that key, CTL, and then we'll set foo to bar, and we should see some output on the other end. And that's typically what we see a lot of people do with etcd when they're first starting out, just have a way of basically communicating to the cluster. And having consensus means that all the other servers will agree on the actual value. This semantic also works for doing locks or leader election. You have like a Postgres master slave, and you want to kind of figure out which one is going to be the master at runtime, they can basically agree on a key, race to lock to that key, write their value, and become the master, and the other one can step down. And then one thing etcd tries to handle for you, if Amazon deletes one of your instances without telling you, it will go through and elect a new master. And ideally, if you're using the entire list of nodes inside your array of things to connect to, none of your writes or reads will drop. It will attempt to roll over to the next node. And once it comes back, it will recover. So that's etcd at a high level. We're using protobufs basically we got burnt really bad last time by using just your typical REST JSON format. And then the API version changed. And that's really painful. You end up basically packing V1 and V2 and carrying that along. Protobufs makes that much easier to deal with backward compatibility on the protocol. So we're going to use protobufs going forward. And we also saw some performance increasing on the serialization. You can imagine dealing with JSON at high speeds is kind of terrible. All right, so that's etcd. All right, the next project that we have is Fleet. And Fleet, since in CoreOS we don't have a package manager, there's no yum or apt-get, which you would find on a typical Linux distro. So we expect people to interact with the cluster from a central place and have a centralized daemon. So what Fleet is, it's our distributed systemd, mainly because you interact with it with unit files that you would see on a typical modern Linux distro. And Fleet also provides access to the particular cluster. So you can actually use SSH to hop into one of the nodes based on this machine ID. And here's the key libraries that we use here. So Fleet is another tool that's built on top of etcd to synchronize the state of the cluster. And GlobalConf and GoINI, I think those are really powerful libraries if you're going to be writing command line tools and you want to have the same flags serve as environment variables for people that don't like seeing a long list of flags on their terminal. And then the crypto SSH package is a godsend, especially if you're trying to support distros or operating systems like Windows, where it's really a pain to get SSH up and going. Using that, it kind of makes Fleet cross-platform in a way. We don't have to ask people to go install SSH. We can use it built in. And for the client API in Fleet, we actually use Google's like API spec, where you kind of define it in JSON and then generate the client libraries from that. So that's been really helpful, even though we're only using it to generate our Go client libraries. If someone wanted to do a Fleet library in Ruby, they can just use the same tools. So I'll give a quick demo of Fleet really quick. How many people have heard of Fleet? You actually use it? No, you just heard of it? Yeah. Okay, that works. All right, so let me get my shell shut up. All right, so I'm going to talk to the other etcd cluster here. So I have a multi-node cluster booted up that hopefully does not rely on the network, because that's going to go badly. So what I'm going to do now is interact with Fleet. I just want to make sure everything is up. All right, so Fleet is actually running. And what I can do is use Fleet to interact with the state of the cluster. So these are all the machines in the cluster. So using the Go SSH library, we can actually SSH into these nodes by their machine ID. And Fleet tries to do the right thing. Oh, look at that, security. And what do people do when faced with this message? Like, what's the point if this is all everyone does, right? It's like, yeah, whatever. Like, steal my bank account records. All right, so we can SSH into the server using Fleet. But Fleet's real power is actually scheduling work into the cluster. So it's a really simple scheduler that allows you to give it a unit file, and it tries to do the right thing to find the right server to run your resources. So in order to do that, I can give it a unit file. So here's memcache. Anyone used memcache before? If it sucks, there's someone here you can actually blame. I'll let you guys figure that one out. So what we can do with Fleet, we're going to use Fleet to launch memcache. So what we're going to do is just start this unit. And if everything works, memcache should actually start running on one of the nodes in the cluster. So Fleet actually figured out that node 140 is actually capable of running this particular unit. So what this unit looks like is we're basically going to download a memcache Docker container, launch it, bind it to the same port as the host. And then I can use Fleet to list all of the units running on all of the machines in the cluster. And my terminal is wrapped, but you can kind of see that Memcache is actually running. And if that's actually true, we should be able to use my trusty, dusty Memcache client to log in and start interacting with Memcache. 11211. Yes, and then, yes, so Memcache is actually running. And Fleet tries to do the right thing. If one of the nodes goes down, it should move that particular job for us, right? So we have it running on 140. One of your new hires kind of gets mad that he didn't get a raise, and he lets you know about it. All right, so now that's down. Your PagerDuty bill goes up a little bit. And then what Fleet tries to do is find a new home for that instance, and it seems to have done so quite quickly. And ideally, we can verify really quick that that actually works. And yes, it does. So that's Fleet in a nutshell. And we basically do leader election because Fleet actually runs on all the machines, but we only need one master. It uses etcd on the back end to do that watch semantic. If one of the nodes dies, it knows it needs to take over its workload. All right. So Flannel. So Flannel is our other project that we've built, and this one kind of gets into some low-level stuff. We use the syscall package quite a bit in Flannel. It drove a lot of people crazy, and luckily we found the netlink library that pretty much solved a lot of the problems that we wanted to do. For instance, we wanted to have VXLAN to do our overlay, and most of the work was already done in the netlink library. We use the Go System D library mainly because we need other services to wait until Flannel is actually up and running before they start. And one way to do that is by using something like systemd and using SD notify, basically putting a message on dbus to communicate to the other services that you're actually up and running and prepared to do work. How many people know what an overlay network is and why you need it? Cool. All right, so I'm going to do a quick demonstration of what Flannel does. So when Docker came out, everyone got really, really excited, especially developers on their single machine. It was like the world had changed. And they ran to their ops team and said, put Docker on every machine. So we did. And once we did that, we had a harsh reality that talking to nodes across machines was not a thing that actually worked really easily. So what I'm going to do here is show the reason that Flannel exists. So we actually have Flannel running on the servers right now. And what we're going to attempt to do here is log into the two machines and demonstrate cross-container networking so that one container can talk to another container. I know this sounds really, really simple, but try someone that is using Docker for the first time, their traffic will go nowhere. And you can laugh as they feverishly try to figure out how to use TCP dump. All right, so here we go. I'm going to log into our second container at this ID. So we'll get on these two machines. Yes, security. Does anyone actually stop when they see a fingerprint that they don't have committed to memory show up? You remember your fingerprints? You should rebuild your servers more often.
Why don't you store the public key hashes?
No, like I suck. Docker run. So what we're going to do really quick is we're going to spin up a BusyBox container. And what we're going to do here is just get a quick shell. And then we're going to do some bash scripting if I remember how. So I want to do ifconfig eth0. And if that works, not O, if that works, we want to start netcat listening on everything that it can find on port 80. Does that look about right?
Yeah.
Sure.
Ship it.
Ship it. All right, so this container got this IP address. So basically, we go to the other node. And we do the same thing, and we want to use BusyBox. And I'm cheating here because I have all my Docker images pre-cached, and that's like really what you should be doing if you don't have great bandwidth or you're at a hotel. All right, so and then here we want to shell again, and then we'll attempt to grab netcat, and we want to, what's the command? Do people know?
You want to do echo and pipe to netcat?
Yeah, too complicated. There we go, and if this works, there you go. All right, we have this bi-directional communication. Now, it looks simple, but trust me, that is golden for a lot of people that just want to work with containers without a bunch of fuss. And the nice thing about this is I'm using, in this case, I'm using Flannel to manage the static routes on the machines. So whenever a new host would join this network, we automatically get our route table updated, so we don't have to do any more configuration. And this is a bunch of static routes to all the other hosts for particular subnets. And the routing table is stored in etcd, so if the machines crash, start Flannel back up, everything's back and happy. So that's Flannel, and it deals with the low-level kernel stuff to make all of your overlay networks just do what they're supposed to do. And the last thing I'm going to talk about is Rocket. So Rocket is a command line tool, and Go, we pretty much use the standard library for that as well. And we leverage the OpenPGP package pretty extensively. Like, that package is pretty great. You know, you can build a whole CA with it. And we use it mainly to build a tool or a system that we can actually verify the application instances or containers that Rocket will actually run. So we recently turned signing on by default. So when you attempt to download your application container, if it's not signed, we blow up. And we built a nice little key store that's hierarchical based on the actual name of the image that we're downloading. We use a nice little tool called IO Progress. So if you're sitting there waiting for something big to download, it's a really handy package to make your UX people smile. And the disv package from Peter is fantastic. We use it for a content addressable store. If you want to get your computer science on, go to Wikipedia and figure out what that is. I'm going to do a quick demo of what Rocket is. Does people know what Rocket is? Sweet. It is our attempt to devalue Docker and make their VCs turn to alternatives. All right, so I'm going to just pick a machine. So what I want to do here is just have Rocket. I don't know if I remember these commands. So I want to have Rocket run a container that's hosted on my Mac. And its name is hello, what release, .0.1, Linux, AMD 64, ACI. Who has money that works the first time? No confidence. Me either. HELLO, // All right, let's cheat a little bit here and see what's actually there. Opt, bin, static. So I'm actually using a Go server to actually host all of these static binaries. So this is the guy. I wasn't off by much, was I? Ah, close. And none of you caught that. Yes. You're on top of your game, buddy. I'm just doing this to see if you're paying attention. Look at you guys. They're just on it. Very attentive. Yes. There we go. So my little hello application's running. I'm using the Go PGP package to actually validate the signature. And we basically turn the file system into a big keychain so we can do this hierarchical magic and also ship vendor trusted keys that you could override by looking at the store. And I'll just Control C this. So in all of our trusted keys kind of live in a directory structure that looks like this. And you also can do them by domain name or IP addresses to trust only certain keys for images stored in certain places. But using those packages took like a day to build this particular feature into Rocket and enable it by default. All right, so that's Rocket. All right, so a thing about the developers at CoreOS. So a lot of them are like kernel hackers, back-end guys. So when they learn Go for the first time, the benefits are you don't see a lot of functions named factory, but you do see things like bitmask being used for function arguments, right? That is like not the thing to do in Go. It's probably acceptable in C, but in the Go world, those are the things we run into, but it's usually not that bad to deal with. You know, we usually do a nice code review and they move on with it. But most of the developers at CoreOS pretty much come from these particular languages, so picking up Go for them is usually like a week worth of effort. You know, they attempt to write some code, a couple code reviews, and they're off on their own. I'm pretty sure we can cut a few days off of that by pairing one day, but the syntax is straight simple that usually there's not a bunch to learn, none of crazy styles that our company chooses to use. But we do have a couple of gripes. So there's like one guy, I won't mention his name. he has like this blog post he's been writing for like 3 months about why Go sucks. And it's all the typical stuff that you see in Hacker News whenever there's a new release of Go, right? Not particularly generics, but things like shadowing bite the hell out of the team, right? Because your code continues to work, and then someone finds out that it doesn't actually behave in the way you think because you're shadowing a variable. And sometimes people aren't as productive, but that's with any new language that you learn, right? You're a master hacker in C, you move on to Go, and then you find out you can't do all that funny pointer stuff that you were doing, crashing the world servers. But in the large part, CoreOS kind of loves Go. Like, oh, let me get to the challenges. So distributions. Debian wants to like rip all your dependencies out and repackage them as separate packages and then reassemble everything on the fly, which doesn't work well at all in the Go world. And we've actually, what's that? Not only Debian, you want to do that too? Oh, Seuss. Oh, you guys. All right, listen, stop that. It's a new world, and
By the way, in Fedora project, we are going to reconsider that. We are going to,
all right, we're going to just have a session. I'm going to buy you beers. I'm going to talk to you guys out of this. Because honestly, I think a lot of our projects got really quick adoption because it was like a static binary, right? You tell the user, download this thing and just use it. And then in the Debian world, it's like apt-get, oh, that old package that they're not going to upgrade for 4 years. And then you're stuck. So that's one thing that we're trying to be nice about it by at least documenting what our dependencies are. So GoDep helps there. We can give them that JSON manifest and say, look, here's the dependencies we have, but I'm not sure how they're going to work out. I need this particular SHA-1. This other package needs this other SHA-1. And you're going to have a huge repository upstream if you're going to try to repackage all of those commits. And again, new language for developers. And finally, at the end of the day, we love Go. So most of us don't even think about it, right? We start a new project, little side things, we're just trying experiments. Go just makes it pretty easy, even to do the low-level stuff. I think a lot of our C guys have gotten used to the syscall interface. They don't seem to get tripped up. And anytime we have a major bug that we run into, we get pretty good turnaround for the next release of Go, patching it. And one of the main features was like user namespaces for some of the container work that we wanted to do. A feature that was really required by Docker and a lot of people using Go to build a lot of this tooling. And that patch landed and we were able to move on. So that's CoreOS at Go. And if you have any questions, I'm happy to answer them. Thank you.
So for example, you can have your machines all on a subdomain of Coreos.com or something like that, and have a central SSH key that can be used to check signatures on these machines. And this way you can just enter.
Yeah, I mean, usually when I'm on my dev machine, I just usually say ignore all that host checking. But in production, yes, you're right. You should probably be doing, validating those things, especially if you're mining Bitcoins. Do we have time for more questions?
Do you pay developers to contribute to the Go project proper or not?
I think all of us are free. I have a few patches that landed. We're not prohibited from doing it during company time. And I think it's because of our open source roots. All of our projects are open source. So anytime we have something to fix, just go fix it properly upstream. And yeah, so yep, on paid time. Any other questions?
Another question, how do you track, especially security issues, new dependencies when you render them in? So do you have something like, did you watch the Git repos for?
I think for the popular so we use very limited set of dependencies to begin with, so that makes it easier to kind of keep track of things. If there aren't any issues, like in our distro, we just cut a new alpha release that rebuilds all of those packages. So the nice thing about building Go packages is straight simple to do. So if we need to update our dependencies using GoDep, we'll bump the particular commit that we need, GoDep save, push, build, and then do a new release, and then do an announcement. But I haven't seen a lot of security vulnerabilities in some of these third-party packages. They're probably there. We don't know about them. Cool. All right, well, thank you guys.